Hello, everybody, and welcome to this last webinar of our webinar series on DIGIFED. So DIGIFED is an innovation action supported by the Horizon 2020 program to drive the digital revolution across European SMEs. So my name is Alice. I am an innovation business developer at Blumorpho. So Blumorpho is a member of the consortium on this project, where we are going to be the innovation management partner, so in charge of the innovation management program. So I'm very pleased to welcome you to this last webinar of our 4-webinar series, where we will welcome today Nathan Coulson and Xaba Kirali from Digital Catapult, Marie-Sophie Maslow from CEA, Jesus Miguel Ruano from Ikerlan, and Andras Pope from Budapest University of Electronics. So as I mentioned, this is the 4th webinar, so the last webinar of our series. We will have all the previous sessions available online for those who didn't manage to make it for the previous sessions. So all the slides and all the videos, recordings of the webinars will be available. So if you were not present, these webinars covered all the technical offers from the consortium, the digital challenge, which is the new type of open call on this project, and the launch of Open Call 2 and how to apply on this second open call. So I would also like to inform you that this webinar is animated today by Blumorpho, and that the slides and recording of this webinar will also be made available for you on the website. There is a question box in the webinars toolbox on the right side of your screen. So please feel free to enter all your questions as we are going through with this webinar, and we will address them to our speakers during the Q&A session at the end of the webinar. So just before I give the floor to Nathan and Xaba from Digital Catapult, and they introduce you to their offer, I wanted to give you a quick reminder about DIGIFED and what has been presented in the previous webinars. So about DIGIFED, it's a Horizon 2020 funded project dedicated to support European cross-border partnerships to foster industry to digitalize their product and services and reach the new markets. So to get to new markets enabled by cyber physical systems, so CPS and embedded systems. So DIGIFED gathers 12 partners from 9 European countries. It lasts for 3 years, from the 1st of January 2020 to the 31st of December of 2022. And it's a cascade funding opportunity for European SMEs. So on this project, there are 2 types of application experiments. The classic called the single application experiment, where a company applies for a 55,000 euros cascade funding to implement the technologies of one of our technical partners in its offer. And the second type is a twin application experiment, where 2 SMEs apply for a total of 110,000 euros cascade funding, so it's 55 each. And one company provides the technical support to the other, so they develop a product together. So if you want to know more about this, you can visit the DIGIFED webpage, so it's digifed.org, and see all the eligibility criteria and the eligible cost. You can also visit the FAQ section, which has a lot of information. All right, so I will now give the floor to Digital Catapult, to Nathan and Xaba. I think Xaba, you're going first. Here you go. Oh, there's a little bug here. Xaba, Nathan, can you hear me?
Yes.
Okay, I give the control of the screen to Nathan.
Thank you. Hello, everyone. My name is Xaba Kirali. I work for Digital Catapult, which is a leading technology innovation center in the UK. Digital Catapult in general have different technology groups in different technology areas, of which we represent here the Internet of Things and AI. And these groups are helping DIGIFED companies. Digital Catapult in general also have activities in other areas. We are helping startups and scale-ups with innovation support. We are managing different accelerator programs and many other things. The offering for DIGIFED is the first one, and the second one will be presented by my colleague, is centered around the Future Networks Lab, which is a facility located in London, and it has extensions also in other parts of the UK. So the Future Networks Lab is has access to technologies and technologies deployed related to different IoT networks. So what we have in the lab is LoRaWAN, Sigfox, NB-IoT, and also LTM. And we also have a 5G network deployed in the lab and also in other parts of the UK. We provide access to expertise and equipment for also on the technologies mentioned before, and also for evaluating energy consumption of different devices in the CPS space. Another part of our offering is providing expertise to TinyML and to AI on small microcontroller-based devices. And this is not just the lab itself, as I said, but we are also having a larger LoRaWAN network to which we can provide access and through this experimentation. And this is spread across different parts of the UK. As I also mentioned, the 5G testbed is not just in London, but also in other parts of the country. Besides this, as the activities of the Future Networks Lab, we are participating to activities of performance evaluation of network protocols. This includes a large variety of network protocols that you can see in the IoT space, from 802.15.4 to and low-level radio protocols to higher levels protocols as part of the stack. Our lab is a physical space, but it's also unique in the sense that we are having different partnerships, unique partnerships in the UK and to international companies. I would mention BT, PTC, IBM, ServiceNow, Semtech, Texas Instruments as examples. But being an innovation hub, we have a larger network of companies with which we can help the companies and help them accessing their products and testing their solutions. So the offering that we have is helping in with benchmarking products in our lab. We can also help in the identification of product improvements, and we can support them in product roadmaps. I think these are the most important points that I should highlight, and I would pass on to my colleague, Nathan.
Thank you, Csaba.
I'm not sure I can move the slides. Yep.
Yes, perfect. Hello, everyone. Thanks for joining the webinar. My name is Nathan Coulson. I'm a technologist on the machine learning and AI team at the Digital Catapult. So just a little bit about AI at the Digital Catapult. So we work in a number of different areas. So one is accelerating AI startups. So we have the Machine Intelligence Garage program, which has incubated and accelerated over 90 AI startups within the UK by providing compute power, advice on AI ethics, and also business and investment support, which I'll talk about later. We also help with increasing AI adoption in industry by, for example, working directly with larger companies or hosting open calls to present the challenges that industry have to the startup and SME community so they can address them. And we also contribute to research such as creating a topology of applied AI ethics tools, which we presented at a large machine learning conference last year. So talk about our kind of capability around AI compute, machine learning, and AI ethics. A lot of this is drawn from our experience running the Machine Intelligence Garage for 2 years, our acceleration program. And our main kind of goal within this kind of support is to first unblock barriers to the development of AI startups in one area, that is providing access to specialist compute power. That can be in the form of access to our on-site infrastructure. So we have 2 DGX1 NVIDIA deep learning servers that we can give access to. We can also give access to cloud credits and vouchers from Google and AWS if needed, as well as working with Chava and the IoT team around potential kind of application or edge devices as well. And in terms of kind of wider support, as I mentioned, we have an ethics committee and advisory group, which provides one-on-one consultations to startups to address some of the practical ethics issues, so they're better able to have conversations with potential customers and address their concerns, as well as building kind of a more responsible AI product in the end. And then lastly, we have kind of the standard business and investment support, and that is something we can definitely discuss and kind of give startups access to, depending on need. But the main kind of goal here is to support the application experiment through the support around compute, ethics support if necessary, and also advisory support from our AI tech team, who have seen kind of many applications of within industry and also within startups as well. And here are some of our partners and collaborators on the Machine Intelligence program, and some recent publications in AI ethics and also machine learning platforms. Yeah, happy to answer any questions you have about the AI program and the support we can offer. Thank you very much.
Thank you, Nathan. So I will now give the floor to the CEA with Marie-Sophie. So Marie-Sophie, you're here.
Yeah. Hello, everyone.
Hello.
So, yeah, thank you, Alice. So I'm working for the CEA LETI, so the Microelectronic Institute of CEA. And today I will present you the offering that is supported by the Laboratory of Cybersecurity at CEA LETI. At the beginning, behind this proposal, there was an internal need to develop a reference board for different needs regarding cybersecurity, like developing tools to test the security of IoT products, or IoT products, let's say, or developing also solutions of security to be embedded on specific boards, also to develop a characterization tool in order to identify vulnerabilities of hardware. So we thought that it could be a good idea to have a reference platform to mutualize some of our developments and best practices. And this is what we are offering to share today. The idea is to use the ARM technology, the trust zone of ARM, that we will embed on a STM32 board. And so that we can provide a richer environment for execution, isolated from a trusted environment. So the idea is that we will add a secure hardware module isolated from the Linux part of the rich execution environment with a specific driver to manage this hardware module. And there will be a dedicated interface between the trusted and non-trusted environment. So the objective is to help our partners develop new applications that will benefit from this specific security setup. And as part of it, yeah, I think I already told it, but one of the uniqueness is really this bridge that allows you to develop an application benefiting from both the trusted world and the untrusted world. So here, what we propose is to implement your applications on top of the ST Microelectronics 32 board with the TPM and Linux as the OS. But just for your information, this is anyway a platform agnostic architecture. So in the longer run, if you need to implement that in another environment, it could be possible. Nevertheless, in the scope of DIGIFED, we push for the STM32 and the TPM with Linux. That's it on my side, Alice, and of course I will be happy to answer to your questions at the end of the webinar.
Thank you, Marie-Sophie. So this is it for the CEA. We will now have Jesus from Ikerlan. Jesus, can you hear me? Yes, good.
Yes.
Do you want to control? I'll give you the mouse and key.
Okay, thank you. So thank you very much, Alice, for this well-prepared webinar. This is Jesus Ruano from Ikerlan. I will give you a brief introduction of Ikerlan capabilities and what we could provide to all partners interested in applying to DIGIFED. So I'm afraid, okay, yeah. So let's get started explaining that Ikerlan is a research center, 40 years old, a bit more than 40 years old. Ikerlan employs around 350 researchers, and we have three units or areas. We have electronics, information and communication technologies, we have energy and power electronics, and we also have advanced manufacturing. And today I'm going to concentrate and I'm going to try to give it to you a summary in 4 topics. All right, so the first one is information and communication technologies, and more precisely in 2 areas, in IoT digital platforms and data analytics and artificial intelligence. So basically the first column, we have a connectivity issues. We have expertise in order to introduce short-range IoT connectivity, low-range connectivity with LoRa, Sigfox, and also 4G, 3G, and special connectivity like low LTE, and also towards 5G. We also make a connectivity to the cloud through different protocols. We are working we are orienting our research to industrial Internet of Things, and that's one of the things I wanted to highlight here is our industrial vision, how used we are to work with customers, since more than 50% of our income comes from customers trying to develop a product or to improve certain features. And also in terms of digital and IoT platforms, we have indoor and outdoor. We have intelligence on things like machine learning and artificial intelligence on edge nodes. This is something that we are working currently. And in terms of data analytics and artificial intelligence, we have digital platforms which are working with in an industrial, for example, industrial environments, in order to make a proper manufacturing and proper monitoring of their products. We have the artificial intelligence and data analytics with predictive maintenance, data lakes for data analytics. We have smart digital platforms with natural interaction with data using chatbots. And also we have development of platforms based on microservices and serverless. So if we move on to the next area is dependable embedded systems. We are, in this case, I wanted to show it to you our experience on safe software engineering and real-time electronics, especially for critical applications, like for example, all those applications where safety is an issue. We have embedded systems developed certified up to SIL 4, which is very demanding in terms of safety. We can go up to SIL 4, but we can also go to SIL lower SILs. We have software development and virtualization for real-time control, automated testing and validation, artificial vision for embedded safety. Our performance or key performance is our long experience in electronics and safe embedded systems. We have safety certified methodology also through TUBE, and we have more than 10 functional safety engineers, one functional safety expert, which is a unique personnel in Spain, and we have different referential on the development of advanced and safety functionalities on SOCs, multi-core, and GPUs. In terms of TRL, we are Ikerlan is an applied research center, so we work with from medium TRL to high TRL, and the applications are very wide. Development of software control for control units on transport, for example, traction and elevation. Also we have development and validation up to SIL 4 with certified applications, for example, railway signaling, and also virtualization of applications and plants, for example, for elevators. So if we move on to the next, in terms of hardware and communication, apart from this embedded software, we have these hardware and communication systems. And in this case, we have a long story and experience on developing hardware and embedded hardware for multiple applications like sensors, low consumption electronics, signal conditioning. We also work with system software like operating systems, drivers, FPGA, and programmable logic in order to accelerate any function that might be needed. And also we have that's one of the things I wanted to highlight also is apart from our pragmatic approach, we have an integration capability. All these issues that I'm telling you, we are able to integrate them into a system. And this is also an important contribution also for extreme conditions or maybe harsh environments. And also non-functional developments like standard compliance tests and troubleshooting in electromagnetic tests, and that's also something that we are taking care of. And in terms of communication systems, we are working with, basically, we are working on real-time communications, like synchronized, in order to make sure that safety is a must, and in order to make sure that there is not safety issues since a probable delay in the communications. So we are working on industrial control and sensorization in terms of real-time communication, antennas, verification and validation, and in industrial connectivity, either wireless or wired. And finally, in terms of industrial cybersecurity, we are cybersecurity is a must right now. It's we cannot, we have to take into account cybersecurity in any connected device, and that's something that we are very aware of. And all our customers and all our collaborators are aware of this issue, and that's why we are developing this protection for embedded electronics and also for digital platforms, from sensors to the cloud. And we are working on secure product development, cybersecurity evaluation, industrial IoT cybersecure communications, cybersecure cloud and user interfaces. And one of our key performances is security lifecycle and certification, and also trust technologies based on distributed layer technologies, for example, like blockchain. And our uniqueness is our certification. We have certified methodologies in order to address compliance of our products or the products from our customers. And we also have cybersecure solutions covering the entire value chain, from the sensor to the electronics and to the embedded software and connectivity solutions, reaching also the digital platform, the analytics. So again, the maturity, it goes starting maybe from 5, 4, and ending in 7. And we are, as I said before, we are applying industrial cybersecurity from the sensor to the cloud. And I'm not going to go farther than that. And I think this is okay. So as an example, I would like to show you 2 examples. One is digital platforms. This is a clear added value that we provide to any customer that needs to provide tools to develop cloud solutions from the edge to the cloud, applying artificial intelligence and also applying microservices oriented to edge devices architectures. So our uniqueness is based on the combination from the sensor to the cloud of all these technologies, in order to be able to make sure that this combination is properly applied and properly and securely deployed. So our key performances is digital platforms based on artificial intelligence, and an application, for, as an example to you, is Industry 4.0, smart factories, smart cities, smart living and aging well, smart mobilities, and smart buildings. So, and also in terms of a more material device like this sensor, we are working on autonomous wireless sensors, taking into account all the issues related to security, to safety, and also in order for wireless communication in real time, with certain capabilities of artificial intelligence, and also in terms of energy. Since it's a wireless sensor, we are developing solutions in order to make this sensor as independent and as autonomous as possible from energy consumption. So the applications are smart logistics, smart factory, like impact or gravity forces or temperature measurements. Also, our applications are related to industry, and taking into account that there are certain non-functional requirements that must be fulfilled, and that makes sometimes these devices more difficult to achieve, but more necessary also. So this basically is our offer. As I told you before, we are applying a different set of technologies, and we are capable of integrating them. And for example, in this device with a safe and real-time software upon connected hardware. So this is an example of integration of all these comments that I showed you before, and this is for this multi-core commercial hardware platform with embedded hypervisors, with software development based on modeling, and with safety concepts. Is applied or can be applied to wind turbine control or operation monitorization or any local recording of key variables. So this is the maturity is quite high, for example, in this case, and can be is up to 6 TRL, and with SEAL 2. So this is Ikerland offer for DIGIFED. We are open to any interested partner to apply to DIGIFED, and in all these sectors, from advanced manufacturing to electronics to power electronics or to sensing capabilities. So thank you very much.
Thank you, Jesus, for your presentation. So our last speaker today will be BME with Andres Pope. So Andres, you're here. Hello, Andres.
Thank you, Alice. Good morning, everyone. I'm András Koppa, the head of the Department of Electro Devices at the Budapest University of Technology and Economics, Faculty of Electrical Engineering and Informatics. Our university is among the largest such universities in Central Europe, and our department has a specialty in reliability and thermal issues of electronics. So we've been participating in the past 25 years in multiple dozens of European projects with these special capabilities. In the last 5 years, we contributed to the Smart Anything Everywhere initiative of the EU, starting with the Euro CPS project. Since then, we have been acting as a digital innovation hub with two special fields, namely with thermal testing, reliability testing, and our offer now is how could I move forward? Sorry.
So just click and then here we
yes.
are.
So with the reliability testing, that's our major contribution. The background to this is that at the end of the day, if you have a digitalized system, a smart system, it will take a form of a hardware, which should be safe, secure, and reliable. And of course, it is not only a software issue, as we could also hear from Jesus in the previous presentation. So longevity and energy efficiency are key. So generic to every smart system, we offer the versatile reliability tester setup at the department. We can provide you various usual reliability tests. That's what we have been doing in the past 5 years with more than a dozen application experiments in various Smart Anything Everywhere initiatives to different European and local SMEs. And we also have a very specialized offer, which is related to semiconductor devices background. That's what we call the LED-B Smart technology, modeling set of modeling methodologies and the workflow for optimized LED-based application design. So yes, So these are the two offers of BME. We can move forward to the next. I'm going to describe in further details these offerings for the DIGIFED application experiments. So let's go forward. A versatile reliability tester is based on a climate chamber, and we detect different thermomechanical related failure modes with thermal transient testing. The beauty of this solution is that this testing can be applied in situ. So while we apply power or temperature cycling according to usual profiles, the tests can be run, and we end up with something which we call structure function. I can also describe later on for any interested people what these really are. They are aging indicators. So here I provide some white paper background on this technology. So that's what we can offer. Other aging indicators can also be considered. And if we move forward, I can describe a bit more detail the LED-related offering through the latest application example, which targeted LED-based system optimization for energy efficiency, taking the advantage of the LED's property that the efficiency is temperature dependent. Therefore, we can optimize the LED-based lighting solution. If we go forward to the next slide. Yeah, that is still this slide. I have a few animations. So the idea is that we can do adaptive dimming to compensate the effect of temperature. And the way of building such a system is based on virtual prototyping, which is shown in the next slide. So the idea is that we replace the physical prototypes. Nowadays, this is still the general practice in the lighting industry to build physical prototypes and test them. What the idea is that you anyway nowadays design anything, any mechanical device in with CAD, and this CAD model could be turned into a multi-physics system model for which the methodology has been worked out in the recently completed Delphi for LED project, where we defined an Industry 4.0 compliant design workflow. And the application example, if we move forward, is the compensation for temperature with which we can achieve roughly 6 to 8% energy saving. Here the TRL level is indicated medium because it always targets a luminaire which is still in the design and optimization phase, and the methodology is not yet implemented by the major EDA companies as a design flow, but relies on standard EDA software tools. But the application of the methodology requires some guidance from our side. So that's what we are offering. If we move further, we can see the way of working. This is a high-level summary of the virtual prototyping workflow offered by the developed in the Delphi 4 LED project. Let's click. This starts with the physical testing of physical characterization of the LED devices, for which we offer our knowledge and other testing hardware infrastructure. What we get out of it is the multi-domain model of the LED devices. So we obtain the physical samples from the partner and we provide the model of the devices. As a next step, the partner provides the MCAD model, or we can also help them generate the system level simulation model of the luminaire. And if this is available, next please, then we can help identify major properties for the implementation of a smart solution. The example I presented previously was temperature compensation, with which constant light output could be achieved, but the partner may define us other objective functions for optimization, which can be also supported with the system level modeling. This is the final step. So if you click again, we prepare the model for the application level simulation. Next, please. This way, the partner can implement the system, and we also offer testing facilities to check whether the implementation meets the objectives. So in this example, I'm showing the test results of the constant light output control, temperature compensated constant light output control, but other objective functions can also be implemented. So what we offer is a strong interaction with the partner. We have a success story example for such a system. So I'm happy to share further details. So I think on the final slide, we can see all the sources of information. Yes. So regarding the DIGIFED Open Call, of course, you find lots of information on the digital website, guide, and application portal. And here you see my email address if you have any question related to the general reliability testing offering and the specific lighting specific technology offer of BME. Thank you very much.
So thank you very much, Andres. So this closes our offer for DIGIFED, and we will now have a Q&A session. So as I mentioned, you have the question box in the toolbox on the right side of the screen. If you have any questions, don't hesitate to address them. We will go through it now. So let's start with the first question. It's a question for Jesus. Will Ikerlan contribute manpower such as expert power? Jesus, are you here?
Yeah, could you repeat the question, please?
Yes. So the question is, will Ikerlan contribute manpower such as expert power?
Such as expert?
Yes.
I'm afraid I don't. I'm not able to understand the last word.
Power. So will you provide an expert as part of manpower?
I guess if I understand well the question, yes, we could provide our advice and our design capabilities in order to maybe contribute or verify the design that is being proposed or how the project is going to be implemented. That's something to be discussed. I'm not able with this information. I just can say that yes, in principle, yes.
Okay, thank you. So next question is for Nathan and Xaba. Do we need to physically be in the UK in order to access the Future Network Lab services? Can we do it remotely? What can we do remotely? And can you explain your value, the value of your partnership for us?
Yeah, so the Future Networks Lab is physically located in London. We are, due to the current situation as well, we are working in making remote what we can. Obviously, access to the equipment and access to the locally deployed networks is not possible remotely. So the typical way is that companies come in to the lab and either do the measurement or we have them with their measurements. We on the expert advice, that's absolutely doable remotely. So there are no limits in that. But the access to the facilities is physically limited.
Okay.
There is the possibility. Just one more thing. There is the possibility to send devices that we test if this is something which we can agree on during the setup of the program. So it's important to say that companies should contact the partners that they can support them and already try to agree on what's possible during the proposal preparation phase.
Okay, great, thank you. So I think there was one last part of the question, which was, can you explain your partnership value for us?
It depends obviously on who you are, but the value is the possibility to test your equipment in a laboratory environment where we have all the test equipment available, and the advice that we can provide in these areas to the extent of the Future Networks Lab. Then we also have the offerings on the AI aspects.
Okay. Thank you, Saba. Thank you for your answer. So if you have more questions, don't hesitate to post them in the question box. One last thing I wanted to mention as well is that on the DIGIFED website, you have a section DIGIFED offer, and you have all the contact details of the people who presented today and last week. So if you have questions directly on the offer, don't hesitate to contact them, and don't hesitate to talk to them and exchange about your projects, because that's very valuable for your application. Another question related to the slides. So yes, we will put the slides and the videos recordings on the website. So you will be able to download the slides. All right, so if there is no other questions to our speakers today, this will close our webinar. So do the panelists have something to add? Otherwise, we can close the session for today.
No, from my side, thank you.
Okay, well, thank you everybody for your attention. Thank you everybody for your presentations, and talk to you very soon. Bye-bye.
Thank you, Alice, for the organization.
Thank you, Alice.
Bye-bye. Thank you, Alice.
Bye.
Bye.
Bye-bye.